In this question, by using this data, I am explaining the part C problem. Okay, if f and g are onto functions, then we are going to prove g circle of composite function is also onto function. So we know that the given functions, f function is the domain is A and codomain is B, g function having the domain B, codomain is C. For this A, B, C sets, I am representing that. So element in the set A, I am representing with X. Element in the set B, represent with the Y. Element in the set C, I am representing with the Z. Now, according to the given condition, I can write the form. If f is onto function is nothing but, so this codomain is nothing but a image of the function f, then which is nothing but, so this images can relates from the each element in the domain value. So how can you write that condition? So that's why x represents the element in the A, y represents the element in the B. Now compulsory in every element in the set A, that only those elements are present in the set B. That's why f of x is equals to y, you can represent. So x images are present in the set B. Set B elements, how can you represent it? Y. Set B elements, you can represent the y. Similarly, you see, these are the x elements, these are the y elements. We can write that f of x is equals to, we can write like this. If g is onto function only, we can write like this. Okay, na? So now if g is onto function, so we know that y is the element of the B, z is the element of the C. How can you write? If it is onto function, simply write it g of y, which is equals to z. We can write it. Okay, na? So in this way, if f and g are onto functions, compulsorily you have to write like this. According to the given sets, you see, it is the x, this is the y elements. I have represented f of x is equal to y. You take it. F of y, g of y is equals to z. You have taken according to the given condition. Do functions are onto functions. Now what we are going to prove it now? G circle f is onto function. We know that G circle f, how can you from it? From these two functions, from the two functions, domain and codomain, we can write it. G circle f is, we write A to C, right? So A is nothing but domain, C is nothing but codomain. But what we are going to prove? It is onto function. So if it is onto function, what we are going to prove? So this should be the image of the composite function, right? You know that A element which is represented by the X element, right? The X, C element, C set elements, we can represent with the Z. Now how can you write it? If it is onto function, so this will happen, right? This we are going to write it. G of X is equals to the Z. If we prove this one, then we can say G circle f is onto function. So that's why we are going to prove that, we are going to show that G circle f of X element, okay na, we will get the Z element which is belongs to the C set. So now we are going to prove this one. Now taking the G circle f of X, I am going to take it. Now I am removing the circle, then plugging in the brackets for the function f of x. Now you see, in place of f of x, in place of f of x, I can write y. Okay, this f of x then replaced by y. We know that again g of y is equals to the z. Okay, according to this, yes, our proof is done.